Now in this lecture we are going to study read-only memory, which is also known as ROM. Now ROM is a device that includes both decoder and OR gates within a single IC package. It is normally used to implement complex combinational circuits in one IC package and eliminates all interconnecting wires between a decoder and OR gates. It is a memory device in which binary information is stored by fusing or breaking internal links in order to form required circuit paths. Information once stored in the ROM is not lost once the electric power is switched off. So it is a non-volatile memory. The information doesn't go away if you switch over your system, your computer. If you switch on again your computer, the information stored in a ROM would stay there and would not be lost. So it's a kind of memory which is known as non-volatile memory or permanent memory. Now the ROM size is mentioned over here. For example, it says 2 raised to power n into m. So let us see what does this mean. This means that this ROM has got n input lines. So the input lines is n. And it has got output lines is equal to m. So this ROM has got n inputs line and m output lines. It means that it will be able to store 2 raised to power n words. The information which it will store would be 2 raised to power n words. And m means that the number of outputs will indicate the number of bits in every word. So the total number of bits stored in a ROM would be 2 raised to power n into m, where m denotes the number of bits per word. So let us physically see the inside construction of a ROM, and whatever I have said over here would be repeated in the next page, which we are going to select. Now let us see the logic construction of a 32 into 4 ROM. So 32 into 4 ROM means that this ROM will have 32 words, and each word will be of 8 bits. So each bit will be of 4 bits, I'm sorry, not 8 bits. So since it has got 4 bits, each word has got 4 bits, it means it will have 4 output lines. And since there are 32 words, so 2 raised to power 5 is 32, so input lines is equal to 5, and total number of bits would be 2 raised to power 5 into 4, that is 256 bits, which will be stored in this particular ROM. Now the ROM is built with the help of a decoder and OR gates. They are in one package. Both the decoder and the gates are in the package. Now since this decoder has got 5 inputs, so the output would be 2 raised to power n, so the outputs would be 32. And it can store 32 words, and each word will have 4 bits. So the number of bits in a word can be seen from the number of outputs. So this has got 4 outputs. And the number of words which are stored in this ROM can be seen from here, which is the inputs are 5, so 2 raised to power 5 is equal to 32. So this ROM can store 32 words, and each word will be 4 bits wide. That is, each word is made up of 4 bits. Now when we want to implement some combinational circuits or Boolean functions with the help of ROM, then we select a particular ROM and then we fuse the links which are between the outputs of the decoder and input of the OR gates. So these links are blown depending on what information we want to store over here. So it will depend on the contents of the words which we want to store, and based on that these links will be either remain in their place or they are blown. So this is how the ROM is constructed. And what is the meaning of 32 into 4 ROM and any other size of ROM can be seen from here. Now these ROMs are of 4 types. The first type is known as read-only memory ROM. Data is stored in the ROM has to be provided by the user to the manufacturer, who stores the data using machine which is designed for this purpose. Data once stored in the ROM cannot be changed. So what you do is that whatever information you want to store in your ROM, you have to make a chart which is showing the information which you want to store, and you have to take that chart to the manufacturer, who will store the desired information into this ROM using a machine which is designed for this purpose. And once data is stored in the ROM, it cannot be changed, because once the fuses which are blown inside, they cannot be repaired or replaced. So once anything written into ROM cannot be changed, and if some mistake occurs, then we have to discard this ROM and use another ROM. This is another type of ROM which is known as programmable read-only memory, PROM. Now difference between ROM and PROM is that in case of PROM, you don't have to go to the manufacturer to store the information into your ROM. What you can do is that you can purchase a PROM, and then you can have a machine at your own home. It is a special programmer machine which you will have to buy, and you don't have to go to the manufacturer. You can yourself burn the data into your ROM. So these kinds of ROMs are known as programmable read-only memories. In this ROM also, once the data is stored, cannot be changed. Now there's another type of ROM which is known as erasable programmable read-only memory. So it is EEPROM. Now the advantage of this PROM is that once you burn the data into your ROM and you want to change the data later on, if there is some mistake, then you can erase the previous data stored and put down your new data into this ROM. And and the previous data which was stored in this can be erased by putting this EEPROM under a special ultraviolet light for a given period of time, maybe 25 minutes, 30 minutes. And once you expose your EEPROM to the ultraviolet light for 30 minutes, then all the information will be erased, and after the eraser you can put the fresh data into your EEPROM. So the advantage of having EEPROM is that if once data stored needs a change, then you can do that. You can change the information. So EEPROMs are more expensive than the upper two types of PROMs. Now the fourth type is electrically alterable read-only memory. Now again this in this ROM we can again erase the information by applying electrical pulses, and we can rewrite data into this ROM. EEPROM and EAROM both are reusable, and they can be reused for more than 100 times or maybe more, depending on the quality of the product. So that's about all. Thanks.